So in the last lecture, after completing group 1 elements, we have started with group 2 elements. Group 2 elements are beryllium, magnesium, calcium, strontium and barium. And in physical nature mein, we have seen them as grayish white, and the softness down the group increases as metallic bond strength decreases, and they are considered to be more harder when compared to group 1 elements. The reason is because of the metallic bond strength. The metallic bond strength in this particular case, group 2 elements, is stronger because you are having 2 valence electrons. In case of group 1, you are having only 1 valence electron. More are the number of electrons which are participating in metallic bond. The metallic bond strength is going to be high. And इस केस में भी हम बेरिलियम को ज्यादा हार्ड मान सकते हैं and बाकी सबको सॉफ्ट मान सकते हैं. And down the group the softness increases. Atomic size down the group it increases. Crystal structures में FCC और HCP के दो structures possible है. We will understand what will be FCC and HCP in the chapter of solid state. For now, just remember they have different crystal structures. FCC and HCP. FCC is called as face-centered cubic. HCP is called as hexagonal closed packing. Melting point and boiling point में beryllium is having the highest melting point and magnesium is having the lowest melting point. Ionization energy, they have greater ionization energies when compared to group 1 elements, and down the group the ionization energy decreases. And इनका ionization energy थोड़ा सा ज़्यादा होने की वजह से they cannot show photoelectric effect using visible light. But group 1 elements जो है they can show photoelectric effect using visible light. This is an important point. Oxidation states, they in general have +2 oxidation state, and all of them majorly forms ionic compounds. Beryllium जो है, beryllium having greater polarizing power, it will be forming covalent compounds. Electropositive character or metallic nature down the group increases as the ionization energy decreases. Density, there is no specific order for density. ये जो order लिखा है, this is we are writing. ये जो order का explanation के लिए लिखा है, this is not the right order. This is the right order. You may or may not remember, but एक बार याद रख ही लेना for safe side. There is no specific variation. In general, in any group, the density varies as down the group it increases. Okay, group 1 में there is only slight variation. Sodium becomes slightly greater than potassium, or potassium becomes slightly lesser than sodium. इस case में beryllium में भी there is some difference. Magnesium में भी there is some difference. Okay. Conductivity. They have more conductivity when compared to group 1 elements because of presence of 2 valence electrons. Agreed? In flame coloration, group 1 elements, all of them can show flame coloration because of their lesser excitation energies. Lithium जो है, it will show crimson red. Sodium shows golden yellow. Potassium show pale yellow. Potassium के बाद rubidium. Rubidium shows red violet and cesium shows violet. Okay, you need to remember all the colors. इस case में beryllium and magnesium, they doesn't show any flame coloration. This is an important point. They are unable to show any flame coloration because of their higher excitation energies. Calcium, strontium and barium, as their ionization energy is less, their excitation energy is also going to be less, so they are able to show some flame coloration. And ये flame coloration के लिए जो भी burner हम use करते हैं, it is called as Bunsen burner. Okay. Calcium is showing some brick red color, strontium is showing dark red, and barium is showing apple green. Okay, hydration energy down the group decreases as charge density decreases. More is the charge density, उतना ही ज़्यादा unstable होगा. In order to attain stability, more and more hydration is going to happen. So hydration energy or hydration down the group, it decreases. In case of complex formation, only beryllium has greater tendency to form complex. उसके साथ साथ magnesium को भी थोड़ा tendency है complex बनाने के लिए. It will be forming complex with chlorophyll, or chlorophyll has the complex of magnesium. Rest all other elements doesn't show any complex formation, but in case of group 1, lithium has the highest tendency, but बाकी elements भी complex बना सकते हैं. Reducing property, there is no different order in the free state as well as in aqueous state. Down the group, the reducing behavior increases because of the decrease in ionization energy. Okay, so barium is highly reducing, followed by strontium, then calcium, magnesium, and beryllium. If I compare the reducing property of all s block elements, lithium has the highest reducing behavior and beryllium has the weak, lowest. Lithium highest इस वजह से है because of its highest hydration energy. Beryllium lowest इस वजह से है because of its highest ionization energy. Is that clear? Reactivity down the group, the reactivity increases because of the decrease in ionization energy or because of the increase in metallic character. Beryllium जो है, it is not even reacting with hot water, but in case of group 1, lithium जो है, it has reacted with steam and the reaction is slow. यहाँ पे beryllium जो है, it is not even reacting with hot water, no reaction. With magnesium, it can react with hot water. Calcium, strontium, and barium, they're able to react with cold water. Okay, is that clear? And the reactivity of group 2 elements is relatively lesser than group 1 elements because of the greater ionization energies when compared to group 1. Reaction with air, beryllium, except beryllium, others are easily tarnished because of formation of oxide layer. Beryllium being less reactive, uska reactivity with oxygen is also, or affinity with oxygen is also less. And down the group, the affinity with oxygen increases. मतलब ये जो rest all other elements, beryllium, magnesium, calcium, they have affinity only for single oxygen. Down the group, as the reactivity increases, strontium and barium can also form peroxide. Okay, is that clear? They can form peroxide, and the formula of peroxide will be PaO2 or SrO2. Peroxide में आपको O2 2 minus रहेगा, peroxide मतलब, right? Peroxide is O2 2 minus. So in order to balance, आपको यहाँ पे strontium plus 2 है तो SrO2 बनेगा, barium के साथ BaO2 बनेगा. Any doubt? Okay, all of group 2 elements will be reacting with nitrogen as well to form nitrites. In case of group 1, only lithium can form a nitride. That is because of its diagonal relationship with magnesium. Rest all other group 1 elements cannot form nitrides. Very, very important. Okay. Group 2 elements, all of them can react with nitrogen to form nitride. With oxygen, they will be forming oxide. Beryllium has less reactivity, hence it is not easily tarnished. Okay. उसके बाद हमने reaction with oxygen देखा है. And down the group, metallic nature increases. If the metallic nature increases, metallic oxides are basic in strength. Okay. Down the group, as metallic nature is increasing, the basic strength is also increasing. So BeO will be a less basic when compared to MgO, CaO, SrO, and BeO. In fact, BeO is amphoteric. Amphoteric matlab it can react with acid as well as base. Why is it amphoteric? Because of its diagonal relationship with magnesium. Sorry, with aluminium. Okay. यहाँ पे amphoteric के साथ ये वाला लिखो. Due to diagonal relationship with aluminium. Is that clear? And amphoteric बनने के लिए ये भी reason है because of its high polarizing power. High polarizing power, it is having some covalent character. As a result, it is becoming amphoteric. And हम ये भी expect करेंगे if it is more covalent, उसका melting point कम होना चाहिए. Ionic compounds will be having greater melting points. Covalent compounds will be having lesser melting points. But in case of beryllium oxide, it has significant melting point or high melting point. The reason for that is because of its polymeric structure. BeO exists as a polymer. Because of its polymer structure, several molecules are attached to each other. As a result, the melting point is becoming high. This is an important point. Okay. Basic order. Okay, I hope this particular order is clear. Hydroxides, beryllium oxide and magnesium oxide are not readily soluble in water. As a result, they won't be forming hydroxides easily. That is because of their strong packing in the solid state. Baaki sab jo hai, they can easily form hydroxide, and down the group, the basic strength increases because of the increase in metallic nature. Okay, basic strength increases. Solubility के केस में आपको कैसे देखना है? You need to see for small anion as well as larger anion. If you are having smaller anion, down the group, the size of the cation is increasing. If the size of the cation increases because of the difference in the size of the cation and anion, what will happen to the lattice energy? The lattice energy will be decreasing at a faster rate. If lattice energy decreases at a faster rate, the solubility is going to increase. Agreed? So जो hydroxides के लिए the solubility increases down the group because OH minus is treated as smaller anion. Is that clear? OH minus, F minus. These two will be smaller anions. Rest all of them will be considered as larger anions. Larger anions के case में down the group packing efficiency बढ़ता जाएगा. If there is achievement of packing efficiency, lattice energy will be decreasing at a slower rate. If lattice energy decreases at slower rate, the solubility is going to decrease. Is that clear?
Yes.
Okay. So hydroxides का solubility down the group increase होगा. यहाँ पे और एक बाद में एग्जांपल दिया है ना क्लोराइड्स का सॉल्युबिलिटी. ठीक है. बेरिलियम हाइड्रोक्साइड जो है, बेरिलियम ऑक्साइड एज वेल एज हाइड्रोक्साइड, इट इज एम्फोट्रिक. एम्फोट्रिक मतलब इट कैन रिएक्ट विद बेस एज वेल एज एसिड. उनका रिएक्शंस शो किया है. whenever it is reacting with base as well as acid, it is forming some complex, coordination complex. It is forming coordination complex because it has higher tendency to form a complex when compared to the other elements. Okay. Hydrides के केस में thermal stability, hydride H minus being smaller, lattice energy is more dominating factor. Thermal stability कैसे देखेंगे? Simple anions, complex anions. Simple anions के केस में lattice energy dominating factor है. Complex anions के केस में covalent character dominating factor है. More the lattice energy, more the thermal stability, more the covalent character, less the thermal stability. Agreed? So ये simple anion का केस हो गया H minus. So down the group, the thermal stability is going to decrease because of the decrease in lattice energy. So thermal stability decreases lattice energy as lattice energy is the dominating factor. Okay. Another important point to remember is beryllium hydride जो है, it cannot be formed directly by reaction of beryllium with hydrogen. You need to react beryllium chloride with LiLH4. Then it is leading to the formation of beryllium hydride. LiLH4 is called as lithium aluminium hydride. Rest all others can form hydrides easily by reaction of that particular metal in the atmosphere of hydrogen. Okay. और एक important point, beryllium hydride and most of the beryllium compounds will be covalent only. यहाँ पे magnesium hydride is also becoming covalent because of the greater polarizing power of magnesium. Beryllium hydride, just like aluminum hydride, exists as a polymer structure. Okay. Exists as polymer structure. In the polymer structure, it is trying to complete its octet, but यहाँ पे pseudo stability मिलेगा, so it is still electron deficient. And the nature of the bond is 3 center 2 electron bond. Agreed? Any doubt here? BH2 जो है वो linear है, but BH2 का polymer जो है, it becomes non-planar. It is becoming non-planar because the hybridization of beryllium is becoming sp3. sp3 मतलब tetrahedral होगा. Tetrahedral is a non-planar structure. Calcium hydride, इसमें calcium hydride जो है, it is important compound for the production of H2 in large scale, and it is used under the name hydrolith. Okay. Okay. Next reaction with halogens देखा है. Halogens में जैसे lithium chloride जो है covalent है, beryllium chloride is also covalent. Lithium chloride has less melting point. Similarly, beryllium chloride will also have a lesser melting point. Okay. ठीक है. उसके साथ साथ हमने solubility के बारे में डिस्कस किया. Solubility के केस में this is a larger anion. Only OH minus F minus are considered as small. Rest all other anions are considered as large. Large anion के केस में down the group solubility decreases because there is achievement of packing efficiency. So solubility decrease हुआ. Any doubt? और ये BeCl2 का you can have 3 different structures. Very very important. अभी questions देखेंगे हम, उसमें सब questions आपको दिखेगा. BeCl2 has a solid structure. It has a vapor structure. Vapor structure में उसका 2 forms है. It can exist as a dimer or it can exist as a monomer. At a lower temperature, it exists as dimer. At a higher temperature, it exists as monomer. अगर temperature बहुत कम है तो it will be existing as a solid, where you will be having 3 center 4 electron bridge bonds. ये bridge bond कैसे बना? Chlorine के ऊपर जो lone pair है, it is given to the beryllium. So in this case, the electron deficiency of the beryllium is getting satisfied. Initially, you have 4 electrons. अब ये 4 electrons भी देने की वजह से it is having octet completion. Okay. So here the electron deficiency is satisfied, but BH2 polymer में there is still electron deficiency because you are having 3 center 2 electron bonds. Here you are having 3 center 4 electron bonds. Any doubt anyone? Okay. Vapor state में less than 1200 Kelvin पे it exists as a dimer. Again you are having 3 center 4 electron bonds, but it is still electron deficient here because you are having 1 2 3 4 5 6 electrons है. So this is electron deficient. The monomer ये तो electron deficient है ही है. Is that clear? And this being covalent, इनका कोवलेंट नेचर ज्यादा होने की वजह से देयर मेल्टिंग पॉइंट विल बी लेसर, बाकी सब आयनिक है इसलिए उनके मेल्टिंग पॉइंट ज्यादा रहेंगे. ओके, ठीक है. Then reaction with N2, all of them can react with nitrogen, and the ease of formation of nitrites decreases down the group. That is because of the size. Nitrite being smaller, it can be stabilized by a smaller cation. Down the group, as the size of the cation increases, the stability decreases. As a result, the ease of formation of nitrates also decreases. All these nitrites upon hydrolysis will give you NH3 along with hydroxide. Any doubt? Okay. In case of group 1, the element which can form nitride, what is the only element that can form nitride?
Lithium.
Lithium. Lithium, that is because of its diagonal relationship with magnesium. Okay. Okay, good. Next, bicarbonates और carbonates के बारे में भी डिस्कस किया हमने. Again, bicarbonates, ये याद रखना, कोई भी bicarbonate upon heating, it will spontaneously convert into carbonate, CO2 and H2O. And bicarbonates का thermal stability हमको देखना है तो this being a complex anion, we will be seeing based on covalent character. Down the group, covalent character decreases or thermal stability increases. Solubility के लिए you need to compare based on ये larger anion हो गया. So lattice energy down the group, there will be achievement of packing efficiency. So down the group, the lattice energy will be decreasing at a slower rate. So solubility decreases. Is that clear? And bicarbonates के case में only group 1 bicarbonates only group 1 elements can form solid bicarbonates. Okay. Lithium and other bicarbonates always exist in solutions. Very, very important. Okay. ठीक. If you are having carbonates upon dissolution in excess of CO2, they will convert into bicarbonate. Okay. Nitrates, thermal stability आप लोग compare कर सकते हो. Any nitrate on heating, very, very important. Any nitrate on heating converts into NO2, O2 and an oxide. In case of group 1, they won't be giving you NO2, they will be giving you nitrite and oxygen. Nitrite का further heat करने से आपको you will be forming oxide, O2 and N2. Remember, बाकी सब nitrates जो है, irrespective of the element, all other nitrates, whenever they are heated, they will be giving you NO2, O2. Is that clear? Okay. यहाँ पे बेरिलियम नाइट्रेट जो है इसको अलग से एक रिएक्शन लिखा. If it is heated, it is forming basic beryllium nitrate. It is forming some basic beryllium nitrate. ये याद रखो अलग से. May be useful. देखते हैं. Sulfates, thermal stability आप लोग कंपेयर कर सकते हो. Solubility भी कंपेयर कर सकते हो. Any sulfate, just like nitrates upon heating, you will get NO2. Sulfates को heat करने से आपको SO2 मिलेगा. Okay. Most of the reactions of sulfur where there is liberation of sulfur oxide, the most common oxide that is liberated is SO2. आपको सल्फर के दो ऑक्साइड्स एग्जिस्ट करता है, SO2 और SO3. SO3 कभी भी लिबरेट नहीं होता और else the reactions are very less where you will be getting SO3. Most of the times you will be getting SO2. So वैसे याद रखो. Okay. Is that clear? Next, solubility in NH3. Group 1 elements can also be soluble in NH3. Group 2 also will be soluble in NH3, and they will be giving out an electron. That electron will be solvated or ammoniated, and which is responsible for conduction, which is responsible for reducing nature, and which will be responsible for color. इस case में, after long standing, the color disappears as those electrons will be reacting with NH3 to form amide. That amide will be reacting with metal to form some metallic amide. Is that clear? Group 1 elements के case में, if and only if you heat that or if you put hot metal in NH3, then only it will lead to the formation of H2 and an amide. But in this case, group 2 elements after long standing, they will be spontaneously converting into amides. I hope that's clear. Solubility के case में, there is only one particular case exception, oxalates. Oxalates being a complex anion. Down the group, if it is a complex anion, down the group, lattice energy will be decreasing at a slower rate or solubility has to decrease. But यहाँ पे देखो oxalates का solubility increase करके दिया है. So remember this as an important exception. Group 2 oxalates, the solubility down the group increases. Is that clear? बाकी सब ऑब्वियस है, कार्बोनेट, सल्फेट्स, क्रोमेट्स, लार्जर साइज, डाउन द ग्रुप, लैटिस एनर्जी धीरे से घटेगा, एज अ रिजल्ट सॉल्युबिलिटी is going to decrease. You have a decrease. Everyone, please put your video on. Prithviraj, Vardhan, please put your video on. Okay. Next, anomalous behavior of beryllium. ये भी हमने पढ़ लिया है. Beryllium is having some anomalous behavior. मतलब most of its compounds are covalent. It is the hardest, but rest all of them are soft, and down the group the softness increases. Melting and boiling points are exceptionally high because of its stronger metallic bond strength. Least reactive because of its very high ionization energy. It forms covalent bonds due to very high charge density. Magnesium maybe some compounds can be covalent, but rest all of them will be forming ionic compounds. It dissolves in alkali. Beryllium being amphoteric. Okay, beryllium being amphoteric. The reason for its amphoteric nature is because of its diagonal relation with aluminium. Amphoteric है तो अगर metal है तो in general it will be dissolving only in acids liberating H2. Non-metals can dissolve in bases, but यहाँ पे क्या हो रहा है? Beryllium being a metal, because we study that as metal, even though it is considered as metal, it is able to dissolve in alkali because it is amphoteric. It has both metallic nature as well as non-metallic nature. Hence, it is dissolving in alkali to form hydrogen. बाकी सब क्या है? They will be reacting only with acids. Only with acids they will be liberating H2. Agreed? So यहाँ पे ये भी add कर रहा हूँ. Only with acids, other elements give H2. Beryllium being amphoteric, it is able to react with base as well, and it is giving H2. Okay. कोई भी amphoteric oxide या amphoteric hydroxide, whenever they are reacting with bases, you will be forming something like zinc react किया तो zincate. Okay. Tin react किया तो और lead react किया तो plumbite और plumbate, stannite और stannate. वैसा कुछ मिलेगा. वैसा ही यहाँ पे sodium berylate और sodium berylate. Is that clear? Okay. Oxides and hydroxides are amphoteric, so इसलिए acid as well as base के साथ react किया है. Here oxides and hydroxides are only basic. Similarly, very important. It can react with carbon to form carbide, but upon hydrolysis of that carbide, you will be getting methane. Rest all other elements upon hydrolysis, they will be producing acetylene. Is that clear? Acetylene is also formed by a group 1 carbide, which is lithium carbide. Because of the diagonal relationship with magnesium, it is able to form acetylene. अभी ये magnesium carbide इसको heat करने से you can form a nude carbide, which on hydrolysis you will be forming propane. This is also an important reaction. Okay, complexes बनाने का tendency ज़्यादा है. It has diagonal relationship with aluminium. Beryllium chloride is covalent. Because of that being covalent, it is non-conductor even in the fused state. Okay, it will be soluble in organic solvents like dissolves like. Its compounds do not impart any color to the flame. Magnesium का भी वही है. Does not react directly with hydrogen. Beryllium hydride बनाने के लिए आपको indirectly बनाना पड़ रहा है. So this is an important reaction. Then we have seen diagonal relationship or similarities with aluminium. I hope all these are clear. Important points are both of them does not react with even with hot water. Next, they can dissolve in caustic alkalis. Because these being amphoteric, they can dissolve in bases liberating H2. Both of them forms bridge bonds in vapor phase. Okay, both of them are forming bridge bonds. Both of them are having ability to form complex ions. और यहाँ पे water के साथ hydration हो रहे हैं, बाकी चीजों के साथ complex ions बन रहे हैं. Both carbides upon dissolution in water, they will be giving methane. Both oxides and hydroxides are amphoteric. I hope those points are clear. Both will be forming polymeric covalent hydrides. मतलब BeH2 n times बनेगा, LH3 n times बनेगा. Then we have moved to calcium and its important compounds. Among the important compounds of calcium, calcium carbonate very important है. Gypsum important है, plaster of Paris भी important है. बाकी सब इनके formula important है, but इनके preparation methods भी important है. Calcium के extraction के लिए calcium again being जो group members again being highly electropositive, they cannot be extracted using normal metallurgical methods. Normal metallurgical methods मतलब क्या है? Reduction using either carbon or carbon monoxide. The other method is whenever I place any metal in the solution of the salt, that metal will be replaced as ions. Okay, वो ions में convert हो जाएगा. Ions जैसा जो भी है वो metal में convert हो जाएगा. This is also not possible because these being highly electropositive, they will always have the tendency to exist in ionic state. They won't be converting into metallic state. So the only successful method is electrolytic reduction. In the electrolytic reduction, you will be using molten or fused salts. उनको melt करने के लिए sometimes we will be adding some other ionic compounds to decrease the melting point. इस केस में CaCl2 का electrolysis के लिए in order to decrease the melting point, we are adding CaF2, calcium fluoride. Is that clear? Okay, ये important है. In Downs process also we have added CaF2 plus CaCl2. Na? We have added a mixture of I think NaCl plus CaF2. Remember what is the mixture added in case of Downs process?
CaCl2 plus
NAF and CaCl2.
NaF and CaCl2. Good. NaF and CaCl2 use किया है कुछ. यहाँ पे ना एक मिनट. यहाँ पे this one we have added the NaF and CaCl2. In this case we are adding CaF2. Remember them separately क्योंकि confuse हो सकते हैं. अभी आपको obvious लगेगा but कुछ दिन के बाद भूल जाएंगे, इसलिए I'm asking you to make only one sheet of paper which has all these important things. Okay, next. Okay, yeah, concept. Okay. In any of the electrolysis process, you will be having oxidation and reduction. Oxidation will always happen at cathode. Reduction will always happen at, oxidation will always happen at anode and reduction will always happen at cathode. No matter what the cell is, no matter what the electrolysis we are doing. कोई भी compound के लिए करो आप लोग, anode पे हमेशा oxidation, cathode पे हमेशा reduction. Cathode पे cations जाएंगे, anode पे anions जाएंगे. Anion being negatively charged, उसको further electrons नहीं दे पाएंगे, उससे electrons लेंगे ही है, इसलिए oxidation होगा. Cations being positively charged, they will be trying to accept electrons, hence वहाँ पे reduction ही होगा. Is that clear, everyone? Okay. Next, other process for extraction of calcium, which uses aluminium. Aluminium के साथ अगर heat किया तो aluminium will be converting into its oxide form, and calcium is obtained as metallic form. This process is called as Goldsmith Alumino Thermite process, also called as Thermite process. This reaction is highly exothermic. As the reaction is highly exothermic, the metal that is formed will be obtained in molten state. Okay. ठीक है. Next, general reactions: calcium with oxygen. Calcium being group 2, it can react with oxygen as well as nitrogen. Oxygen के साथ oxide बनेगा, nitrogen के साथ आपको nitrate बनेगा. With hydrogen, it can directly react with hydrogen to form CaH2, which is used as a starting compound for the preparation of H2 on large scale. CH2 को पानी में मिला दिया तो you will be getting CaOH twice plus H2. So this is used as hydrolyte for the preparation of H2. Any doubt? Then this can react. Calcium, strontium, barium जो है, they can react even with cold water because the reactivity is high. Beryllium doesn't react even with hot water. Magnesium will be reacting only with hot water. Calcium जो है, it reacts with cold water to form H2 as well as base. Any metal upon reaction with water, acid के साथ definitely H2 तो मिलेगा ही है. Upon reaction with water, water के अंदर से भी आपको H positive आएगा, metal के अंदर से आपको electrons आएगा. H positive and electrons will give you H2. OH minus जो left हुआ है, it will be reacting with this to form hydroxide. Any doubt? Okay, next, quick lime, which is also called as burnt lime. The preparation method is heating limestone, which is CaCO3. CaCO3 को heat किया तो आपको CO और CO2 मिलेगा. ये जो particular reaction है, heating of CaCO3, have we discussed any preparation method which involves this reaction? Anyone? Do you remember any preparation method of any other compound which involves heating of CaCO3.
Sodium carbonate.
सोडियम कार्बोनेट एंड सोडियम बाइकार्बोनेट का प्रिपरेशन मेथड्स जो है इसी को यूज करते हैं ना. We will be heating this to form CO2. The formed CO2 will be passed through saturated solution of NH3. That NH3 will be reacting with CO2 to form ammonium bicarbonate. That ammonium bicarbonate reacts with NaCl to form sodium bicarbonate. That sodium bicarbonate being less soluble, it can be separated out. उसको जब हीट करेंगे, it converts into sodium carbonate. Sodium bicarbonate is washing soda. Sodium bicarbonate is baking soda. Agreed? Everyone remember? Okay. Which is used in fire extinguishers?
Baking soda.
Baking soda, which is NaHCO3. Okay, NaHCO3. NaHCO3 along with H2SO4 acts as a fire extinguishing material. Okay. होता क्या है, एक बार थोड़ा सा डिविएट कर रहा हूं. H2SO4 जो है, it will be reacting with sodium bicarbonate NaHCO3 to form H positive. इसको दे दो, it converts into H2CO3. H2CO3 is an unstable compound, so it immediately converts into CO2 and H2O. So these two are responsible to extinguish the fire. Okay. H2SO4 जो है fire extinguishers में there is some fitting, right? Whenever you remove that H2, there will be a reaction between these two. Because of the reaction between these two, you are going to form H2CO3. H2CO3 being unstable, it converts into CO2 and H2O. This will be coming out and that will be extinguishing the fire. Is that clear? Okay. 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 So you can, ये सब हम इसलिए देख रहे थे. COCO3 का heat किया तो you'll be forming CaO and CO2. Preparation method for CaO, which is quicklime. Action of water, CaO, whenever it is dissolved in water, it forms something called initially slaked lime. Okay. If you are putting in, suppose calcium oxide ज़्यादा है, उसके ऊपर पानी थोड़ा amount है, there will be formation of cracks. That cracks appears as slakes, hence it is called as slaked lime. Suppose बहुत ज़्यादा पानी डाल दिया आप लोग उसमें, बहुत ज़्यादा पानी डाल दिया तो क्या होगा? Some amount of CaOH will be soluble and some amount of it will be insoluble. The insoluble part is called as milk of lime, which is used in whitewashing. The soluble part will appear as clear solution. That clear solution is called as lime water. Slaked lime matlab everything is a variation of CaOH only. In slaked lime, the amount of water is going to be less. In case of milk of lime, you are having the precipitate of the CaOH twice. In case of lime water, you will be having more and more amount of water, or it is a clear solution. जो भी CaOH twice इसके अंदर dissolve हुआ है, वो lime water है. Dissolve नहीं हुआ है, that is milk of lime. Okay. And the other thing is slaked lime. If you are having some less amount of water, it will be called as slaked lime. Quicklime is also called as burnt lime. Remember these extra names, because in the options you will be seeing these extra names in order to confuse you. Okay. Next reaction with carbon. It is reacting with carbon to form calcium carbide, which on hydrolysis you will be getting acetylene. Beryllium carbide will give you CH4. Aluminium carbide will also give you CH4. Rest all other carbides will be giving you C2H2, acetylene. Okay. Lithium carbide also will give you acetylene. Important. This on reaction with N2, it will be forming a mixture called nitroleum. CaCN2 plus carbon. This is called as nitroleum, which on dissolution in water produces ammonia. As a result, it is used as a fertilizer. Okay. So nitroleum ka composition, how it is prepared, that is also important. Nitroleum. All metallic oxides, in general, metallic oxides are basic in nature. Only exceptional behavior will be of beryllium. It is amphoteric. But this being basic, it can react with acids. Acids मतलब non-metallic oxides हो जाएंगे. So calcium oxide plus non-metallic oxide, आपको salt मिला, CaSiO3, calcium silicate. Calcium oxide plus non-metallic oxide, which is acidic, again आपको salt मिला, which is calcium phosphate. Any doubt in these reactions? These are obvious reactions. Okay. इनको ये जो reactions हैं obvious होना चाहिए आपको. These are the reactions which you won't be writing in the separate sheet. क्योंकि ये मेटलिक ऑक्साइड है, नॉन मेटलिक ऑक्साइड है, एसिड बेस रिएक्शन आपको सॉल्व बनेगा करके पता होना ही चाहिए. ओके, दिस इज द रिएक्शन व्हिच यू नीड टू पुट इन दैट पर्टिकुलर शीट, क्योंकि ये अलग रिएक्शन है ना. दिस इज आल्सो एन इंपॉर्टेंट रिएक्शन. ये पुट करते समय आपको पैरेलली बेरिलियम हाइड्राइड के बारे में लिख लेना होगा. बेरिलियम हाइड्राइड, सॉरी बेरिलियम कार्बाइड. बेरिलियम कार्बाइड व्हेनेवर इट इज डिसॉल्व्ड इन वाटर आपको CH4 मीथेन मिलेगा. ओके, इज दैट क्लियर? बेरिलियम कार्बाइड के साथ आप एल्यूमिनियम कार्बाइड को भी यहाँ पे ऐड कर लेना. सो ओके, सो अंडरस्टैंड हाउ टू फॉर्म दैट नोट्स. एक सिंगल शीट नोट्स जो भी आप बना रहे हैं, दैट शुड बी योर फाइनल रिवीजन शीट. ओके, वंस यू रीड दिस चैप्टर, आप लोग परफेक्ट हो गया तो दैट पर्टिकुलर शीट मस्ट बी सफिशिएंट फॉर यू टू रिवाइज द एंटायर चैप्टर. समझो ये बात है. If you are able to form that particular sheet which covers all the things, with the help of which you will be solving all the questions, you are done with the preparation of this chapter forever. Clear?
Yes, sir.
Okay. Next, it is used in manufacture of bleaching powder. जिनका reaction हम देखेंगे आगे. It is used in the manufacture of bleaching powder. It is used as a basic lining for furnaces. These two are important things. बाकी सब भी आप लोग याद कर सकते हो, but these are more important. Calcium hydroxide, also called as slaked lime. The other form it can be milk of lime, and the third form of it can be lime water. Okay. Whenever it is dissolved in water, it will be forming calcium hydroxide, and this is an exothermic reaction. Okay. Metallic oxides are basic in nature, so इसलिए पानी में मिलाने से आपको obviously base मिल जाएगा. Calcium hydroxide, it is used for test of CO2. Lime water जो है, whenever I am passing CO2 through lime water, initially there will be formation of white turbidity. That milkiness or white turbidity is because of formation of calcium carbonate. But that white turbidity or milkiness disappears whenever I am passing excess of CO2. Whenever you are passing CO2 through carbonate, any carbonate will be converting into bicarbonate. This bicarbonate being soluble, the milkiness disappears. Okay, so this is used as a test for CO2. CO2 को जब भी lime water के through pass करता हूँ, initially it will be forming milkiness. The milkiness is going to disappear whenever I am passing excess of CO2. Is that clear? Okay. Baryta water, you can have the similar purpose. It is also used as a test for CO2. Similarly, पहले आपको barium carbonate मिलेगा, which is milky. Upon passage of excess of CO2, the milkiness disappears because of formation of barium bicarbonate. Any doubt? Okay. CaOH twice with Cl2, it will be forming CaCl2 plus calcium hypochlorite. The similar reaction with NaOH. NaOH plus Cl2. Cold condition पे you will be forming hypochlorite as well as NaCl. Hot condition पे आपको chlorate मिलता है. Okay. So irrespective of the condition, यहाँ पे आपको हमेशा hypochlorite मिल रहे. Calcium chloride along with calcium hypochlorite, it is called as bleaching powder. Okay, this combination is bleaching powder. Sometimes आपको bleaching powder का formula ये भी दिख सकता है, CaOCl2. Okay, CaOCl2, ये दोनों के बीच में रिएक्शन हो गया, आप लोग CaOCl2 भी बना सकते हैं. Okay, CaOCl2 ये हमने redox में पढ़ा है, if you remember. CaOCl2, it is formed from Ca2 positive, OCl minus as well as Cl minus. जो OCl minus it is formed from HOCl, Cl minus it is coming from HCl. Okay, so this can be treated as a mixed salt. HCl और HOCl से बन रही है. CaOCl2 is also bleaching powder. The combination of CaCl2 plus calcium hypochlorite. This is also bleaching powder. Remember this. Okay. ठीक है. Next, mortar. It is formed by combination of 1 part of CaOH twice, 3 to 4 parts of silica and water, which is used as a construction material. Okay, mortar. So this is also important. Next, it is used for removing hardness, and temporary hardness can be removed by calcium hydroxide. Permanent hardness नहीं remove होगा. In the chapter of hydrogen, we will understand that hardness of water, all the reactions, specific reactions. As of now, just remember it is used for removing hardness of water. It is used as whitewash. The milk of lime, it is used as whitewash, preparation of bleaching powder, and purification of sugar. Okay. Next, यहाँ तक हम already cover कर चुका है. Next, calcium carbonate, which is CaCO3. Calcium carbonate is formed by reaction of CaOH twice with CO2. And calcium carbonate जो है दो form से हमारे लिए है. One is called chalk. Chalk is the soft form of calcium carbonate, and the other is marble. Marble is the hardest form of calcium carbonate. Okay. Whenever you react calcium hydroxide is a base. Carbon dioxide, CO2 जो है, it is acid because it is non-metallic oxide. Non-metallic oxides are acidic in nature. आपको चाहो तो you can also write the reaction in a different way. CaOH twice मतलब it will be present in water only. So वो जो water H2O और CO2 पहले इन दोनों के बीच में reaction करके you can form H2CO3. H2CO3 is an acid, COH twice is a base. दोनों के बीच में reaction करवा लो. You'll be forming CaCO3 and H2O. Okay. Either you can react directly with CO2 or you can react that with H2CO3. होता क्या है, CO2 इसमें मिलने से पहले H2CO3 मिलेगा. That H2CO3 will be reacting with calcium hydroxide to form CaCO3. Any doubt? Okay. Ammonium carbonate के साथ and calcium chloride. This is also an important reaction. There is displacement reaction. ये जो calcium है, ये जो calcium it is going with carbonate and ammonium ion जो है it is going with chloride. Ammonium chloride मिला, आपको calcium carbonate मिला. This is double displacement ना. This reaction is called as double displacement. This is displacing this and this is displacing this. Any doubt? Okay. याद रखो ये calcium chloride with ammonium carbonate, it will be giving me calcium carbonate and ammonium chloride. यहाँ पे और एक reaction भी आपको फ्यूचर के लिए लिख रहा हूँ, which is an important reaction. Ammonium carbonate को heat करने से you will be getting NH3. Ammonium carbonate upon heating, you will get NH3, CO2 plus H2O. The heating reaction of ammonium carbonate will lead to the formation of NH3, ammonia. Is that clear? Okay. Calcium carbonate is insoluble in water but dissolves in presence of CO2. यही है ना test for CO2. Calcium carbonate, down the group the solubility decreases. Agreed? Down the group the solubility decreases. What is the reason for that? Carbonate being a larger species, down the group lattice energy will be decreasing at a slower rate. If it is decreasing at a slower rate, the solubility is going to decrease. Calcium carbonate जो है उसका ही solubility कम है, तो strontium carbonate और barium carbonate उनका solubility और भी कम रहेंगे. Okay. But it can be made to be soluble whenever I'm passing CO2. The reason is because of formation of bicarbonate. This is a reversible reaction. मतलब इसको CO2 के through pass किया तो आपको bicarbonate मिलेगा. Any carbonate on heating will get back carbonate. Remember, any bicarbonate on heating, you will be getting carbonate. Okay. It is used in toothpaste. It is medicine for indigestion. Important है, calcium carbonate जो है, it is used as a medicine for indigestion. I hope all of you know it is present in toothpaste, cosmetic powder. It is used as a building material. It is used in the manufacture of, अभी देखेंगे सीमेंट का. It is used in the manufacture of cement, glass, washing soda. Washing soda में use होता है ना? Remember washing soda? CaCO3 को heat करके हम CO2 लेके आके CO2 को pass करके करते हैं. So it is used in the preparation of washing soda, obviously quicklime. Next, I hope this is clear. Let's go to next compound. This is very, very important compound, gypsum, calcium sulfate. Gypsum जो है, the naturally existing state of calcium sulfate जो है, it is CaSO4.2H2O. It exists naturally as the dihydrate CaSO4.2H2O. and you can prepare that by reacting CaCl2 with H2SO4. You will be forming HCl and you will be forming CaSO4. Preparation method आसान ही है. CaCl2 upon reaction with H2SO4, you are forming CaSO4 plus HCl. Any doubt? This will be absorbing moisture and it will be converting into CaSO4.2H2. The naturally existing state of CaSO4 itself is gypsum. Okay. ये जो gypsum है, see here, whenever I am heating gypsum, it is converting into CaSO4.half H2O, which has lesser quantity of H2O, which is called as plaster of Paris, which is again used as a building material, POP, which on further heating, it is converting into CaSO4, and this is called as dead plaster or dead burnt plaster. Important है, you need to remember the temperature conditions. अभी questions करते समय आपको दिख जाएगा. Everyone, please put your video on. If you are heating at 120 degrees, you are getting plaster of Paris. If you are heating that at a higher temperature, you are getting dead burnt plaster. What is soda ash? Soda ash.
Calcium carbonate.
Soda ash, calcium carbonate नहीं है. It is not calcium carbonate. It is sodium carbonate. Soda ash. How to remember? Washing soda, baking soda. Both of them are NaHCO3, Na2CO3. Washing soda का formula जो है, it is Na2CO3.10H2O. If you are removing water from anything, okay, it is called as ash. मतलब resultant compound is called as ash. So soda ash, it is formed from washing soda, hence it is Na2CO3. Is that clear? Na2CO3 is called as soda ash. यहाँ पे CaSO4, if I am removing entire water, it is called as dead burnt plaster, which is obtained at 200. Mains में आपको direct questions आएंगे. They will give you this. They will give you the temperature condition. एक टेम्परेचर 120 डिग्रीज पे आपको प्लास्टर ऑफ पेरिस मिल रहे हैं, 200 डिग्रीज पे आपको डेड बर्न प्लास्टर मिल रहे हैं. You need to mark this reaction separately in that particular sheet. Very important. You will definitely going to forget this क्योंकि 120 200 क्यों कैसे याद रहेगा. Okay, is that clear? And ऐसा भी याद नहीं रख सकते हायर टेम्परेचर पे ये है, लोअर टेम्परेचर पे ये है. हायर एंड लोअर रिलेटिव है ना. 400 डिग्रीज कैन बी हायर. ओके, सो क्वेश्चन में आपको 200 दिखता है. They won't be giving two different temperatures. अगर दो different temperatures दिया तो definitely मैं ये मार्क कर सकता हूँ, lower temperature पे plaster of Paris, higher temperature पे dead plaster. Okay, if they give only one temperature, we don't know if it is a higher or lesser at the end. मतलब 2 साल के बाद बात कर रहे हैं हम. अभी आपको याद हो जाएगा temperature, but बाद में याद नहीं रहेगा. Is that clear? Okay, very important. इन दोनों को अलग से याद रखना. Next, this is also an important reaction. It forms an important fertilizer, which is ammonium sulfate. The reaction is calcium sulfate upon reaction with NH3, CO2 and H2O. Reaction भी आसान है. CO2 और H2O ये दोनों कंबाइन करके बनता क्या है?
H2CO.
Ammonia is a base. H2CO3 is an acid. इन दोनों के बीच में रिएक्शन करके you can form ammonium carbonate, NH4 twice CO3. इन दोनों के बीच में रिएक्शन करके you can form that ammonium sulfate and calcium carbonate. Calcium chloride के लिए भी ऐसा ही कुछ similar reaction देखा. If it is reacting with ammonium chloride, ये तो देखा हमने. हाँ, यहाँ पे calcium chloride के लिए calcium chloride with ammonium carbonate, you got ammonium chloride and calcium carbonate. यहाँ पे भी वही हुआ ना, similar reaction, ammonium carbonate. This mixture will be giving you ammonium carbonate. CO2 और H2O combine होके आपको H2CO3 मिलेगा. That H2CO3 will be combining with ammonia. Reason, this is a base, this is an acid. Ammonium carbonate मिल रहा है, which on reaction with CaSO4 आपको calcium carbonate और ammonium sulfate मिल रहा है. This is an important fertilizer, ammonium sulfate. Okay, plaster of Paris के लिए अलग से uses लिखा है, important. It is used in setting broken bones. It is used in making casts for toys as well as statues. It is used in making blackboard chalks. Okay. POP is used in making blackboard chalks. Okay, but recently blackboards so abhi aa nahi rahe na. We are having only markers and all these things. But government institutions में अभी भी blackboards ही है. So important है. Remember this. Last very important compound, cement. It is light gray heavy fine powder. I hope everyone knows this. Cement is light gray heavy fine powder. Very important. Cement is made up of silicates and aluminates of calcium. ये जो cement है, cement का composition जो है, majority of the composition 90%, more than 90% of the composition is contributed by silicate and aluminate of calcium. Silicate मतलब आपको SiO2 का form, aluminate मतलब it is made up of Al2O3. Okay, silicate and aluminate of calcium. Silicate में आपको exactly लिखना चाहो तो it has to be SiO3 करके लिखेंगे. Silicates usually SiO3. Okay, but we are writing it separately. It is combination of calcium oxide as well as silica. इन दोनों के बीच में reaction होके आपको calcium silicate मिलता है, which is CaSiO3. You can write that as CaSiO3 कर सकते हैं. Okay, I am representing that separately as calcium oxide and silica. The reason is इन दोनों के बीच में reaction करके ही हम silicate बनाते हैं. Okay, this is called as tricalcium silicate, where you are having 3 CaO dot SiO2, मतलब 3 CaO units है और SiO2 है. This is dicalcium silicate. It is made up of different silicates. It has tricalcium silicate, it has dicalcium silicate, it has tricalcium aluminate, it has tetracalcium aluminoferrite. Okay, this entire composition, this combination is called as cement. Tricalcium silicate मतलब 3 CaO dot SiO2. Dicalcium silicate, we will be having 2 CaO dot SiO2. Tricalcium aluminate, you will be having 3 CaO dot Al2O3. ओके, कैल्शियम ऑक्साइड और Al2O3 इन दोनों के बीच में रिएक्शन होके आप लोग कैल्शियम अल्यूमिनेट बनाते हैं. ओके, यू कैन राइट द फॉर्मूला ऑफ दैट एज CaAl2O4, बट यू आर हैविंग अगेन सम यूनिट्स ऑफ CaO, इसलिए अलग से ऐसा मार्क कर रहे हैं. यू आल्सो रिमेंबर द फॉर्मूला लाइक दिस ओनली. इज दैट क्लियर? ओके, अदर इंपॉर्टेंट पॉइंट्स. Dicalcium silicate is the one which is responsible for slower setting of the cement. The other component, which is tricalcium aluminate, it is responsible for fast setting of the cement. Which is more advantageous, slow setting of the cement or fast setting of the cement? Fast setting. Whenever cement sets suddenly, fast setting से आपको cracks मिलता है. Okay, you will be having cracks in that particular system construction. Slow setting say you can avoid those cracks. Okay, so better component is this. Slow setting ही important है. This is the slow setting component. This is fast setting component. And ऐसा भी नहीं होना चाहिए बहुत धीरे-धीरे. For the construction of one particular building, आप लोग बहुत साल लगा रहे. Okay, you need to have some good mixture of these two, good composition of these two, so that time पे भी बच सकता है, as well as the construction also will be of good quality. Okay, ठीक है. Next, so remember all these things. Just remember one major thing. Cement is nothing but silicate. It is made up of mixture of silicates and aluminates of calcium, and these are the different silicates and aluminates which are present. So remember this. Preparation. It is prepared by using limestone. Limestone से आपको CaO मिलेगा. If you heat limestone, you will be getting CaO plus CO2. From clay. Clay is the source of that alumina and silica. Alumina is Al2O3, जिससे aluminate बनेगा. Silica is SiO2, जिससे silicate बनेगा. Okay. And gypsum, CaSO4.2H2O. If you are adding all these things, आपको ये मिलेगा, ये composition मिलेगा. ठीक है? There is no separate preparation methods, individual reactions हमारे syllabus में नहीं है. So don't worry about separate things. Just remember the composition. In the composition, if you see, CaO accounts to the major amount, which is 61.5%. They will be asking which particular component is of highest amount. कैल्शियम ऑक्साइड आपको सबसे ज्यादा रहेगा और क्विकलाइम सबसे ज्यादा है, followed by silica, followed by Al2O3, right? Alumina. बाकी सब जो components है those are present in very minor amounts. Okay, three major components are calcium oxide, silica and alumina. These two combine to form calcium silicate. These two combine to form calcium aluminate. And there are different types of silicates and aluminates which are listed here. Is that clear? Okay, setting of cement. When water is mixed to cement and the mixture is left, it becomes very hard. This property is called as setting. Okay, already mortar के बारे में भी हम पहले भी कुछ लिखा है. Mortar कैसे बनता है? Cement plus sand plus water. It is also called as mortar. Cement plus sand plus water. Concrete is cement plus gravel plus water is called as concrete. RCC, reinforced concrete cement. Okay, it is nothing but concrete filled in beams of iron bars, which impart extra strength to the structure. It is nothing but concrete. That concrete will be filled around iron bars, which is called as RCC. So ये भी पूछते हैं आपको. This is also asked, what is concrete, what is mortar, and what is RCC. Just remember whatever is written in the notes. काफी है. Let's go to solving questions. Everyone, end of S block. End of S block. In the next chapter, we will be going to study P block. उससे पहले solve these questions. ये जो questions है, this is a combination of hydrogen as well as S block. Hydrogen अभी हमने पढ़ा नहीं है, so उन questions को अभी के लिए रुकते हैं. We will be solving other questions which are exclusively of S block. दूसरे बैच के लिए हाइड्रोजन भी हुआ है, so they may attempt those questions later, हाइड्रोजन के questions. But बाकी लोग, let us first solve questions of S block only. See question number 1. This has appeared in advanced 2020. 2020 advanced मतलब recent. Okay. Which of the following liberates O2 upon hydrolysis? Which of the following liberates O2 upon hydrolysis? It is only single option question. With the help of options, you can get the answer. Please tell me the answer. What do you think?
CO2.
KO2? KO2 is right answer. KO2 is absolutely right. If you remember, आपको मैं 3 reactions अलग से दिया है. I have asked you to remember the reaction of oxide with water. Lithium oxide less reactive है, so sodium oxide का reaction लिखते हैं. Oxide with water, the peroxide with water, NO2, O2 with water, and superoxide. Superoxide is formed by potassium, rubidium, and cesium. इसलिए उनका ही लिख रहा हूँ. This with water, you will be forming only one product. This with water, you will be forming 2 products. Superoxide with water, you will be forming 3 products. ऐसा याद करो. This with water, you will be forming NaOH. You will be forming 2 NaOH. This H2O2 है ना? It is salt of Na2O2 is salt of H2O2. So यहाँ पे आपको H2O2 मिलेगा और आपको NaOH मिलेगा. ओके. H पॉजिटिव इसको दे दिया, OH माइनस जो भी है Na पॉजिटिव को दे दिया, NaOH plus H2O2. If you are warming it, if you are heating it, in that case this H2O2 dissociates to form H2 and O2. So इस केस में भी उसको हीट किया तो ये H2 और O2 में कन्वर्ट होगा, and ये H2O कैंसिल होकर आपको O2 ही दिखता है, or else you will be having only 2 products. Remember, KO2 को पानी में जब मिलाने से आपको प्रोडक्ट क्या मिलेगा? You will have KOH, ये भी मिलता है, H2O2 भी मिलता है और O2 भी मिलता है. You will be getting 3 products. If it is given in more than one option question, तब आप लोग Na2O2 और KO2 दोनों मार्क कर सकते थे. And Li2O2 doesn't exist ना, ये बनता ही नहीं. लिथियम पेरोक्साइड नहीं बनेगा. लिथियम forms only oxide. Okay, so D नहीं मार्क करना है. Na2O2 भी मार्क कर सकते हैं if it is given more than one option. Considering warm condition, warm पे आपको O2 मिलेगा. यहाँ पे सिंगल ऑप्शन में दिया है irrespective of the condition KO2 will always give O2. So इसलिए better option is B. Is that clear? Okay. यहाँ पे next हाइड्रोजन का हो गया. Let's for now skip this question. बाद में देखते हैं. Okay. Let's go to question number 3. Question number 3 करो अभी. You can solve question number 3 now. You can solve question number 5. I will mark all those questions which you can solve right now. Okay. Let's solve question number 6. Hydrates का question हो गया वो. 10th question is an important question. You can solve 11th. Okay, solve these questions. जो भी mark किया है, please solve them right now. Questions 3, 5, 6, 9, 10, 11, 13. बाकी सब हाइड्रोजन के हैं. Once we complete the chapter तब देखते हैं उनका. Want to explain something from question number 4, even though you don't know about hardness, please try to attempt that question. Okay, I hope it's done. हो गया क्या? Okay, take your time. Can I discuss? Third question तो आप लोग कर लिए होंगे. They are asking about NaOH plus Cl2 hot and concentrated. They are asking about hot and concentrated. Hot and concentrated पे आपको chlorate मिलेगा. Everyone put your video on. Hot and concentrated पे आपको NaClO3 chlorate मिलता है ना. If it is dilute, you will be having a hypochlorite. Hypochlorite. NaClO is called as hypochlorite. But यहाँ पे hot and concentrated दिया है. And COH twice, irrespective of any of the condition, it will always form CaOCl2. So what is the answer? COCl whole twice. और यहाँ पे option A. Okay. Question number 4 देखो. The temporary hardness of water sample is due to X. Boiling this converts X to compound X and Y. Boiling this sample converts X to compound Y. They're asking about X and Y respectively are. ये जो temporary hardness जो है, it is because of presence of bicarbonates of magnesium as well as calcium. ये एक बार अरमान ने भी आपको पढ़ाया है. Remember, it is because of presence of bicarbonates of calcium and magnesium. So option में आपको A भी हो सकता है. बाकी सब में दिया है. सब में bicarbonate से दिया है calcium और magnesium का. Whenever I'm heating a bicarbonate, what is the product? It converts into carbonate. But do you see any of these things as carbonate? यहाँ पे आपको मैग्नीशियम का कार्बोनेट दिया है. Everyone, यहाँ पे they have not given calcium carbonate, so obviously ये गलत है. And they have not given calcium carbonate even in here. This is important. Carbonate को heat करने से, bicarbonate को heat करने से, you are going to get magnesium carbonate definitely. वो पहले आएगा. बाद में क्या होगा? It will be reacting with water to form MgOH twice. Everyone understand this? यहाँ पे हो क्या रहे? Initially there is bicarbonate. That bicarbonate upon heating definitely it will be converting into carbonate. But as it is present inside water, water के अंदर रहने के वजह से it will further react with water to form magnesium hydroxide. Very, very important. Magnesium carbonate has the tendency to form hydroxide. Hence, this magnesium bicarbonate is also referred to as basic magnesium carbonate. मतलब it can dissolve in water to form MgOH twice. CaCO3 जो है, everyone, CaCO3 जो है, it cannot dissolve in water. अभी देखा हमने. In order to dissolve CaCO3, what you need to do? You need to pass CO2, then it will be converting into bicarbonate, which is soluble. Remember? Am I audible, everyone?
Yes, sir.
Okay. यहाँ पे options में you have option C, which is MgCO3. You may be tempted to mark that option because MgCO3 तो मिलेगा ही है. But MgCO3 being soluble, it converts into MgOH twice. Okay, it converts into MgOH twice. Calcium bicarbonate को heat किया तो आपको CaCO3 मिलेगा. CaCO3 is not soluble. If it is not soluble, आपको यहाँ पे COH twice, I'm sorry, यहाँ पे आपको COH twice नहीं मिलेगा. So the better options among A and C is option A is better. Is that clear? Okay. Calcium bicarbonate अगर in case रहा, उसको heat करने से calcium carbonate. If there is an option which has calcium carbonate, because it is removed as calcium carbonate being unstable, it will be removed as calcium carbonate. Is that clear? Okay.
Yes, sir.
Okay. ठीक है. Next, question number 5. The incorrect statement is lithium is the strongest reducing agent among the alkali metals. It can be the right option. It can be the right option provided it is given in aqueous state. If it is in aqueous state, that is the strongest reducing agent. एक बार बाकी ऑप्शन भी चेक कर लेते हैं. If it is in free state, lithium is the weakest reducing agent. Option B देखो, lithium is least reactive with water among the alkali metals. That's the right statement. चैतन्य बहुत हंसी आ रहे तुम्हें. ओके ठीक है. ऑप्शन बी जो है इट्स राइट स्टेटमेंट. ऑप्शन सी देखो, LiNO3 lithium nitrate decomposes on heating to give LiNO2 and O2. Is this a right statement? Option C.
No, sir.
It will form NO2, right? This is the wrong statement. Lithium nitrate को heat करने से you will be forming NO2, O2 and oxide of it, Li2O. Right? Okay. Next, question number 6. The metal that gives hydrogen gas upon treatment with both acid as well as base. मतलब जो भी amphoteric है वही करेगा. Amphoteric के लिए जिंक इज एम्फोट्रिक.
जिंक
आपको अलग से याद रखने के लिए सब बहुत सारे कहा है. जिंक, टिन, लेड, एल्यूमिनियम, दीज आर एम्फोट्रिक. ओके, सो यहाँ पे बेरिलियम रहता तो दैट कैन आल्सो बी द आंसर. बेरिलियम इज आल्सो एम्फोट्रिक. क्वेश्चन नंबर 9. हाइड्रेशन. डाउन द ग्रुप as charge density decreases, hydration also decreases. Okay, A is the answer. Sorry, Li D, option D. 10th, bio students can answer this. JEE students may not answer this. This is very important application in biology. Any bio student, Shivdatta, please tell me the answer for this. Shivdatta, are you there? You think A option? The answer is
third ही बता.
okay. The answer is okay. The answer is B option. 1, 2, 3 सारे right है and bio students ही इसका आंसर दे सकते हैं हमें. They activate many enzymes. If you open NCERT textbook, उसमें पोटेशियम के कुछ यूजेस दिया हुआ है. उसमें आपको दिखेगा, सारे ऑप्शंस दिखेगा. Okay, the exact logical explanation only bio students may be knowing this. Maybe, I don't know. They activate many enzymes. Na positive, K positive, both of them are used in activating enzymes, right? Bio students, please correct me if I'm wrong. Along with sodium ions, they are responsible for transmission of nerve signals. ये भी सही है. Okay, they participate in the oxidation of glucose to produce ATP. ADP कुछ तो रहता है वैसा बायोलॉजी में. ठीक है. This is given in your NCERT. So remember these things. Mark this separately as the uses of potassium, K positive potassium ions in your separate sheet of paper. Is that clear? Question number 11. A metal on combustion in air forms X upon hydrolysis with water yields H2O2, O2 along with another product. 3 products कौन देता है?
RB.
Superoxide.
Superoxide can be formed only by RB. Okay. Group 2 elements जो है they can form only peroxide. Superoxide नहीं बनता है group 2 से. And peroxide B, they can be formed only by barium and strontium. Remember? Okay. Question number 13. The hydride that is not electron deficient. Answer? C होगा SiH4. Silicon hydride. Because silicon का outermost shell में 4 electrons है, 4 electrons bonding में जा रहे हैं, octet completion हो गया. Aluminium 3 electrons है, 3 ही जा रहे तो 6 electrons. Boron B2H6, BH3 is electron deficient, B2H6 is also electron deficient. गैलियम सेम फैमिली मेंबर है, एल्यूमिनियम जैसा ही. You are having 3 electrons, only 3 electrons are participating. You have 6. Octet completion ही हुआ, octet completion नहीं हुआ. Is that clear? Okay, I have posted some more questions here. I will post this now. So try to complete as many questions as possible from this block. If you are having some questions related to hydrogen, you may leave them for now. बाद में जब हाइड्रोजन पढ़ेंगे तब कर सकते हैं. Thank you.